Hello, everyone, and thanks for joining me again today. I'll be continuing my work on parsing. So last time, for those of you who followed, I managed to parse input like this. So this is a very simple fork in isolation. This is not placed alongside any other blocks. So I'm planning to change this today. I thought I would be brave enough to nest forks inside one another, but I think that will come. But for now, I just want to focus on introducing a collection of blocks where a fork can be one element in such a collection. So if we can parse something like this, action 2, I think that will be a big success for today. So sequences, let's go here. Oh, sorry, I realized that I'm not showing my screen. Apologies. So I would like to start parsing collections like this. And before we dive in, I hope you have your drink of choice ready. I managed to make some coffee for myself. And the reason I'm mentioning it, I think this might be the best AeroPress coffee I've ever made. So enjoying every sip of it. Delicious. All right, so let's go back to our Lexer. So this is how a list of tokens is defined right now. And it looks like I'll have to change this in order to introduce the concept of a collection, which element can be a fork, or which elements can be forks. So what happens if we just do fork? And before we go there, let's take these two out. For now, I just want to make sure that we can parse it using the new parsing production rules. So this is my fork, and fork is a fork block that has 3 inputs, I believe. Out of range, okay. Interesting. But the fork block only takes 1 argument. Surely that is not correct. Let's do this. uh, I'm not sure if this is going to work, but it's worth a try. Oops, no. Where were we? Here. this be better? Let's see the source. So is this telling me that this is block? Yes, okay. Let's see if we can still parse it. Yes. Let's try to add action too. See what happens. Mm-hmm. Okay, so at this moment, I'm not really sure if this is working well, if I'm doing the right thing. We're only getting a parse error. This is, let's just confirm, it is because of the presence of that fork block. It's not. Well, it is because of the presence of this. Let's run a different exercise. Let's only try to parse one single action like that. See if it works. Oh, so we have a problem here. it again. Okay, so I'm doing something really wrong here. Let's try to experiment with that error token, see what it tells us. Let's see what we get now. So no error tokens. Monadic parsers. Okay, let's do that. But first, let's restore what used to work. Here, the fork should still work, I think. And it does. Adding monadic parsing support, adding monadic support to your parser couldn't be simpler. Just add the following directive to the declaration section of the grammar file. I think this is here. Type, then return. Okay. It does look very simple. Type constructor for the monad. Then it's the bind operation of the monad, and return is the return operation. If you leave out the names for the bind and return operations, Happy assumes that type is an instance of the standard Haskell type class monad and uses the overloaded names for the bind and return operations. And this declaration is included in the grammar. Happy makes a couple of changes to the generated parser. The types of the main parser function and parse error, the function name there, repeats the name of the monad type constructor, and the function must be polymorphic in A. In other words, Happy adds an application to the return operation defined in the declaration above around the result of the parser. Parser is affected because it must have the same return type as the parser, and that's all it does. This still isn't very useful. All you can do is return something of monadic type from parse error. How do you specify that the functions can also have type PA? Most of the time you don't want the production to have this type. You'd have to write explicit return piece everywhere. However, there might be a few rules in grammar that need to get at the end, get at the monad. So happy has a special syntax for monadic actions. Okay. The percent in the action indicates that this is monadic action, the type P of A, where A is the real return type of the production. When happy reduces one of these rules, it values the expression. Happy uses result as the real semantic value of the production. During parsing, several monadic actions might be reduced, resulting in a sequence like expression then R1, expression 2, then R2, etc., etc. Okay, so let's see. Take a look at the Haskell parser for a good illustration of how to use a monad in your parser. It contains an example of all the principles discussed in this section. Okay. Examples. A full Haskell 98 parser written using Happy is available from the GHC CVS repository. Let's do monad test. So let's do this. The type here is P. Then P, return P. And this is not an array or a list. Oh, the monad serves two purposes. Let me make this a bit larger. It passes the current line number around. It deals with success failure. I think this is brilliant. Let's just shamelessly copy the entire section. Oops, sorry. And return P. Print. Now, how do we use this? Run calc. So we need parse result. And now, haskell tokens. In our case, name is diagram. Okay. But we also need to expose this type. Parse result. Oh, sorry, it is a scan tokens is a Lexer function. Okay. Let's do this. What was the result again? Parse result. Oh, it's a polymorphic function. Let's see. Nothing scope. Parse okay, parse fail. I thought it was in scope. Should it be like this? Let's expose everything for now. Oh, sorry. That should be one. So the diagram does get parsed. Let's introduce an error here. Parse error 12. This is because we're printing the length of the list. Okay. We have some error tokens. That's good. We have tokens. Parse error. So if I remove everything from the input except the action, and it should still produce an error. Let's try to comment this out. This we don't need. Name, token type, monad. Let's see. All right. Parse error in line 1. That's good. Thank you. What happens if we push it down here? That's going to be action 4. Still in line 1. All right. Just looking at the time, we're slowly running out of it today. I don't feel we've gotten far today, but at least we added monadic parsing with a degree of error handling. Let's see. This is going to be not correct. Okay, I think we're going to leave it for today. And I'll have to do some reading off camera. How to extract more information from those errors. And we'll see. Yeah. For now, I thank you all very much for your attention, especially on a Monday. I hope you stick around to see what else we can extract from this parsing adventure. And yeah, I wish you all a fantastic day ahead. Bye. Take care.